Hi everyone, welcome to video lecture series from Damnhit.com. Today let's see how to convert gray to binary and from binary to gray code. For conversion of any code, we need an XOR gate. So let us first look at the truth table of an XOR gate and then let us proceed to the conversion. XOR gate truth table is very simple. This is a basic XOR gate symbol. If A and B are its inputs, the XOR gate truth table is like this. If both the inputs are same, then the output of the XOR gate will be 0. If inputs are different, then the output of the XOR gate will be 1. You can remember in this way for convenience, or if you want to remember the XOR gate truth table in its old fashioned way, then you can remember anyway 0 0 0 0 1 1 or anything you like. So let us see how to convert binary to gray first. For this, there is a small rule. In binary to gray conversion, we do XORing horizontally. I'll show you an example for this. Let me take 100 binary code. Before we start conversion, we will see this is MSB and this is LSB. For binary and gray code, MSB is always the same. So we can directly write MSB as it is. Then we need to do XORing horizontally, as I said. We will have to XOR these two bits. 1 and 0, it is 1. Right? 0 and 0 XOR, it is 0. That's it. We have got our equivalent gray code. You see, we will take the MSB as it is, then we will XOR horizontally. 1 and 0 XOR is 1, 0 and 0 XOR is 0. We will get the equivalent gray code. For getting the equivalent binary code from a gray code, then again the rule is the same one. MSB is always the same for binary and gray, so we can write MSB directly. And now we will have to XOR diagonally. 1 and 1 XOR, it is 0. Again diagonally, 0 and 0 XOR, it is 0. So we get the equivalent binary. So 1 0 0 in binary is equal to 1 1 0 in gray, that is equal to again 1 0 0 in binary. We did this conversion. Now I would like you people to take a pen and paper and do the conversion along with me. Let us do simple conversion for usual binary numbers. Let me take from 001, 010, 011, 100, 101, 110, 111. These are the normal binary numbers. We will now convert them to gray code. As we can see, I have told you previously, MSB is always the same. If we are converting binary to gray, then we will have to do XORing horizontally. 0 and 0 XOR, it is 0. 0 and 0 XOR, it is again 0. The same thing, MSB is always the same. I'll write it for your clarity. We are doing binary to gray. 0, we will take MSB directly. 0 and 0 XOR, it is again 0. 0 and 1 XOR, it is 1. MSB is always the same. 0 and 1 XOR, it is 1. 1 and 0 XOR, it is 1. 0, MSB is the same rule. 0 and 1 XORing, it is 1, 1 and 1 XOR, it is 0. MSB is the same. 1 and 0 XOR, it is 1, 0 and 0 XOR, it is 0. 1 and 0 XOR, it is 1, 0 and 1 XOR, it is 1. MSB is always the same. 1 and 1 XOR, it is 0, 0 and XOR, 1 and 0 XOR, it is 1. MSB is always the same. 1 and 1 XOR, it is 0, again 1 and 1 XOR, it is 0. So guys, that is the equivalent gray code. Now let us convert it back to binary again. Same rule applies. MSB is always the same for both binary and gray. But for gray to binary conversion, we will have to do XORing diagonally. 0 and 0 XOR, it is 0. And again 0 and 0 XOR, it is 0. MSB is always the same. 0 and 0 XOR, it is 0. 1 and 0 XOR, it is 1. MSB is the same. 0 and 1 XOR, it is 1. 1 and 1 XOR is 0. You can see we are getting the equivalent binary code again. When we are converting from gray to binary, we are getting back the equivalent binary code again. So that is a good verification procedure. 0 MSB is the same. 0 and 1 XOR, it is 1. 1 and 0 XOR, it is again 1. MSB is the same. 1 and 1 XOR, it is 0. 0 and XOR, 0 again. MSB is the same. 1 and 1 XOR, it is 0. 0 and 1 XOR, it is 1. MSB is the same. 1 and 0 XOR, it is 1. 1 and 1 XOR, it is 0. See, we are getting the equivalent binary code back. MSB is the same. 1 and 0 XOR, it is 1. 1 and 0 XOR, it is 1. So we got the equivalent binary from gray. We have converted binary to gray and from gray to binary. It is the same if you have to convert more than 3 bits or more than 5 bits, you can use the same procedure. This is applicable for any number of bits. You can expand this procedure to any number of bits. There is no restriction at all. Now, let us look at a simple circuit that which can directly convert binary to gray and from gray to binary. As I said, only an XOR gate is needed, so we will try to design a simple equivalent logic for converting binary to gray. First, let us see binary to gray. I will represent binary numbers. I will take a 4-bit binary number this time because we'll be able to look at the circuit more clearly with 4 bits. B3, B2, B1 and B0. B3 is MSB here. As I said, MSB will always remain the same. So MSB goes outside without any logic involved. Now look here, what are we doing? We are trying to XOR the MSB bit with its next bit. So we can take the MSB bit, we can take the next bit, put an XOR gate here, then give it out. It will be the next gray code bit. The same applies here. Then we are taking here the next binary bit and XORing it with LSB. So we will do the same again. We are taking the next binary bit, doing an XOR. Same thing again. We are taking one bit here, LSB, and then XORing it. We will get G0. And if we have to convert gray to binary, then we will have to, as I said, we'll have to XOR diagonally, right? Anyway, I will take 4-bit again. See, remember the rule. MSB is always the same for both gray or binary. Now, what are we doing? After we take the MSB out, we are taking this MSB and XORing it with the next bit. So, we will take output from here. We will take this bit. We will put an XOR gate and we will get the equivalent binary. The same thing again. After we get this bit, we are XORing it diagonally with the next bit. See guys, I'm using the terms diagonally, horizontally, just for ease of convenience so that you people can remember it easily. But there is nothing like diagonal XORing, or it is just XORing of consecutive bits. So it is just for ease of convenience. So I'm taking the output of this bit and XORing it with the LSB, getting B0. So that is a very simple and very easy to understand code converter logic equivalent circuit. Alright, now I'll give you people a tip. Many times even I forget which one is horizontal, which one is diagonal, or something like this. So I'll give you a tip. Binary to gray, right? Binary to gray. You remember this B, first B? In this letter we have a very good bulge. See, we are doing XORing horizontally, right? You remember this as B. B's bulge in the letter. We'll write MSB. We will do XOR. It is 1. We will do XOR and it is 0. Right. In the letter gray, we have G. See, we can make use of this curve to remember diagonal XORing. First we write the MSB, we XOR diagonally. So this is similar to G. We XOR, and after that 1 and 0 XOR, it is 1. We again do XOR diagonally and it is 1. 1 and 0. So we can get back, we can follow this procedure. Alright guys, so this is how we do conversion from gray to binary and from binary to gray. I will put the scanned copy of this document for your convenience in the below link. Please do visit damnhit.com. There are still more number of video lectures available there. You can find any technical digital logic related videos and transistors, devices related videos, or methodologies of verification. Any VLSI related video, you can find it in damnhit.com. Thanks for watching and all the best.